Okay, up until now we have been doing area bounded between curves without really realizing that that's what you were doing. We've actually been doing this back from October when we first started integration. Prior to this, we had found the area bounded by a curve and the x-axis. So that curve could have been below the x-axis or above, but we were simply finding the area that was bounded. When we do the integral, however, the height of the y function, f of x, times the area length of the base, could be positive or negative. So this is really just height of the y function times the base dx. So if the height of the y function was negative, we would actually lose area. Now, when we compare that to what we're going to do now, what we're really doing when we're saying bounded by the x-axis is we're saying that we're doing from A to B, technically f of x minus 0 dx. So the area between y equals f of x and the x-axis, which is y equals 0. What that means is when we're subtracting, f minus 0 is positive when the y value for f is positive, but f minus 0 is negative when we're upside down like this. What we're going to be doing now is the area between two curves. What's nice is we're really doing the exact same thing. We're still doing height times base, but the height of the rectangles is actually the part between the two curves. So we still have height of the function, but now the function is the difference of the functions times the base across an area. So the height of the rectangles is no longer determined by just one function. It's determined by two functions. And again, the height is the difference of those two functions. What's nice about this is that the formula works regardless of whether the functions are above or below the axis. If I say f minus g in this case, the g value is negative, but a positive minus a negative is still positive. So we're still finding the difference between f and g is our height, and the dx is our base. So we're still doing height times base. So for example, if the height here is 1, and down here the function is negative 1, then the height of the rectangle right in the center is going to be 1 minus negative 1, or 2. The height is 2. So it doesn't matter if part of the function is above or below anymore, because we're not doing f of x minus 0 and having a negative value because 0 is bigger than f of x. So here, f of x is smaller than 0, so smaller minus larger is going to be a negative. Okay, also, when we do two values that are already negative, it doesn't matter if they're both negative. We're looking for this height. So if this were, per se, negative 1, and this was negative 10, the top function, f minus g, is going to give us negative 1 minus negative 10, 9. So this height would be 9. So it doesn't matter where the functions fall, below or above the axis, when we're talking about area bounded. It's still going to be height times base. Okay, so this is a free response question every year. Every year on the AP exam, one of your FRQs is going to be this type of question. So that means, hopefully, that you're going to be happy about that because you know how to do this type of question. You've really been doing the idea all year long. And this is always the part A. The part B is always going to be a rotated area that makes a volume. So we're going to have a volume question for B and C. One of them is going to be the volume of a cylinder or cone type shape. We'll talk about that tomorrow. And one is going to be the volume of cross sections, which we'll do the following class after that. Okay, so it depends on what we're doing, but every year, area, volume, volume. So it's nice to know that you're prepped up for a specific question already on your free response. Okay, now, for example, on this one, we do need to know what our parent functions look like so that we can figure out which function is on top and which function's on bottom so we can get the height appropriately as a positive height. So for us, we have the x squared function as the red function on my graph. The green function is y equals negative x. We are starting at x is 0 and stopping at x is 1. So that's the boundary for the area of our shape. Now the height of our shape is still going to be determined by the difference between those curves. So if we're starting at x is 0, stopping at x is 1, the height is going to be x squared plus x plus 2 minus the negative x function. So make sure it's minus negative x, that you don't write this down incorrectly. And really, I am not going to simplify any of this. Please do not simplify anything for your very first written down statement. On the free response question, you are probably going to get 2 points that you're going to put in the bank. They're your points. You cannot lose them if you write this down correctly to begin with. So it's one function in parentheses minus the next function in parentheses. You can't lose those points if you mess up the algebra later. They can't be taken away from you. So go ahead and write it down unsimplified. Okay, so then if I were anti-deriving, I would probably simplify before I did the antiderivative. So x squared, x minus negative x is actually plus 2x, and then plus 2 dx. So I'd antiderive and get x cubed over 3 plus x squared plus 2x from 0 to 1. So if this were a free response question, I would simply substitute in 1/3 plus 1 plus 2 minus 0 and be done with it. I wouldn't move on from there. If it was a multiple choice question, I would want to get this simplified out. So I can think of this as 3 1/3, but your multiple choice would be an improper fraction, so that's going to be 10/3. So my multiple choice answer would be 10/3. For this next graph, I know that 6 minus x squared is an upside down parabola and that y equals x is a straight line. I would just graph an upside down parabola. I would probably substitute in x is 0 to get that it crossed through 6 and just make an upside down random parabola and then draw y equals x. So I'm looking for the area bounded. So that's the area that's closed off between the curves. Now I would need to know where these curves intersect. So I would set the functions equal. In my calculator, if I had my calculator, I could do y1, y2 and intersect. But for this, we need to be able to do this by hand. So I'd have positive x squared. We have a positive x and then minus 6. This would factor as x plus 3 and x minus 2. So x would be negative 3 and x would be 2 at the intersection. Now I always have people say, well, couldn't I have just looked at the graph and kind of guessed that? No, the graphs are not going to have a grid behind them for you to guess that that's where they intersect. You're going to have to be able to find the intersections algebraically or with your calculator. And you never estimate if it's between values. Okay, so this is definitely negative 3 for the x value and definitely 2 for the y value. So my integral for the area is the base starts at negative 3 and ends at 2. The height is the difference between these two curves. So the height is determined by, I'm going to start off here, the upside down parabola minus the line x dx. So we have the height, the difference in the y values, times the base. So if I were anti-derive from negative 3 to 2, I would probably simplify first. 6 minus x squared dx. So the antiderivative is 6x minus 1/2 x squared minus 1/3 x cubed from negative 3 to 6. So this is really, as far as the arithmetic is concerned, your worst case scenario for a multiple choice. If this were a free response, again, I would substitute in. I would get 36 minus half of 36 minus 1/3 of whatever 6 cubed is minus negative 18 minus half of 9 minus 1/3 of negative 27 and leave it. I really wouldn't even have to simplify out the 6 squareds and the negative 3 squareds or anything like that. I could just leave the problem. If it were a multiple choice, again, this would really be the worst case scenario. You would have 36 minus 18 minus 72 minus negative 18 minus 9 halves plus 9. So I would have on here negative 54 minus negative 9 minus 9 halves. So if I were finding a common denominator, I would have negative 108 over 2 plus 18 over 2 plus 9 over 2. So putting all that together without my calculator, I would probably do these 2 at a time. So I would do 2 at a time and get negative 108 plus 18 is going to be negative 90. Alright, I just realized something. I substituted the wrong value in. There's no way that was going to work and be a positive value. I messed up. I wrote 6 instead of 2. Got a little ahead of myself there. So start again. Plugging in. I get 6 times 2 is 12 minus half of 4 minus 1/3 of 8 minus negative 18 minus half of 9 minus 1/3 of negative 27. At least I caught it eventually, right? Okay, so then I would have 12 minus 2, which would be 10 minus 8/3. And again, this is a worst case scenario for having to put this together. Negative 18 minus 9 halves plus 9. So then I would have 30 minus 8 over 3 minus, and here I would have negative 9 minus 9 halves. So I have 22 over 3 plus, I could write this because I'm going to distribute this through, so it's going to be plus 18 over 2. So I would have 27 over 2. So our common denominator is now 6. So I would have 44 over 6 plus over 6. 27 3 times is going to be 81. So then I end up with 125 over 6. So that would be like the saddest one to have to get ever on your multiple choice. And again, if this were a free response, I would have stopped here. Okay, for this one, no calculator allowed. You have to know the graph of cosine and sine well enough to know who would be on top in this particular area. So x equals 0 is the y-axis. And the first intersection. We have to know without our calculators that the first intersection is pi over 4. And we probably should know that that occurs when the y value is root 2 over 2. Because cosine of pi over 4 and sine of pi over 4 are root 2. We should definitely know how high this goes. If x is 0, the y value would be 1 on the cosine graph. And this would be 0, 0 for the sine graph. So if we're looking for the area, we're looking for the height of the functions. So the height of the area is determined by the difference. So starting from x is 0 and stopping at pi over 4, that's going to be cosine minus sine dx. So antideriving, the antiderivative of cosine is sine. The antiderivative of negative sine is positive cosine. And we're integrating from 0 to pi over 4. So that's going to be sine pi over 4 plus cosine pi over 4 minus sine 0. Well, I should move that down. Let's move it. So we'll do sine pi over 4 plus cosine pi over 4 minus sine 0 plus cosine 0. Now, because the A part of Calc AB includes some of the pre-calc material, you have to show that step. I can't leave it this way. So I would have root 2 over 2 plus root 2 over 2, parentheses, sine of 0, which is 0, cosine of 0, which is 1. So on a free response, I could leave it that way. On a multiple choice, they're going to put these together. Half of root 2 plus half of root 2 is 1 root 2, and minus 1. So this will be my multiple choice answer. Okay. Now the area enclosed here, you would need to be able to set this up without your calculator. So I would need to know basically if they were to give me the graph of the functions without the grid in the background, I should know what these functions look like to know that the cube is the red one and the negative square is the blue one. What's going to happen though is without my calculator, I would have to be able to find the intersection. So I'd have to be able to set these functions equal. So I would have 2x cubed minus 2x squared. Sorry, take that back. The x squareds are going to cancel. So I'm adding over. And then minus 18x equals 0. So if I factor out the GCF of 2x, I'm left with x squared minus 9 equals 0. And we know that I've said many times that difference of squares is one of the favorites for AP. So x equals 0, and x doesn't just equal 3, it is plus and minus 3. So we have x equals negative 3, x equals 0, and x equals 3. Now this problem is a little different because we don't have one function winning the whole time. We're going to have to do this in pieces. So for the first piece, between negative 3 and 0, the height is determined by the cube minus the square. And again, the parentheses are absolutely necessary. First function minus the parentheses, second function. Plus, the area for the next part starts at 0 and stops at 3 is the square minus the cube. Okay, now a function that has this many pieces you are probably not going to have to do by hand. You would simply want to get the area on your calculator. So I'm a little lazy. I don't want to punch all this in twice. Okay, and then what they would do if this were a non-calculator question, meaning you had to find the intersections by hand, they would say something like write, but do not evaluate. So you would just have to do the setup and all your points would come from here. Okay, so otherwise I would put one of the functions into y1, so 2x cubed minus x squared minus 14x and 4x minus x squared. I would probably make a note for myself. I may not put calculator notation ever inside of the space where my answers belong on the AP exam. However, I can make a note somewhere else up in the stem of the problem or in a margin somewhere so that I could then do the integrals from negative 3 to 0. And we want cube minus square, so y1 minus y2. Plus, and I can go ahead and type the next integral without having to start over, the integral from 0 to 3. And this time it's the square on top, so y2 minus y1. my answer is exactly 81. So this wouldn't have been a crazy one to do by hand, except for the fact that the simplification and everything would have had to been done first. And you do have to make sure you're doing the two separate areas. You don't want to have this area and then end up subtracting part of the other area because you have the curves backwards. Okay, now we also have situations where the curves are not distinctly on top of each other. Okay, so in a situation like this, where we have the function that's in terms of y instead of x. So especially the y squared equation. So what you want to think of on that is that if you had this function, you want to think about it being turned over, because before we were doing upper minus lower dx because we had a top y minus the bottom y. When the functions are in the other direction, we're going to have to do right minus left for a dy question because it's the right hand y, or the big X minus the little x. So the bigger value minus the smaller value. So when we have curves on top of each other, the big Y minus the small y gives us a positive length. We want the big X minus the little x to give us a positive length as well. And so we want to kind of think about this as turned over. So now we're talking about this space, and it's the bigger x, the positive x, minus the negative x, vice versa. So, if we're looking at this problem, without a calculator, we would have to be able to do the integral. So notice that my x equals 3 minus y squared. If I tried to solve for y to do this the way we did before, top minus bottom, my y would have to be plus or minus the square root of x minus 3. That's why this is in two different colors. It's actually two different functions. We don't want to do that. Instead, we're going to look for this area bounded here by doing this as a right minus left question, because then we have a distinct winner the whole time. So one x value is always bigger than the other x value. Okay, so if I set the functions equal to find the intersections, 3 minus y squared has to equal y plus 1. 0 would have to equal y squared plus y minus 2. So if I factor, I would get y plus 2, y minus 1. So y would be negative 2 and y would be 1. So the integral is going to be negative 2 to 1, because technically this is my base now, and this is my height, because it's turned sideways. And we're going to do the square function minus the linear function. Now the nice thing about this, I just wanted to show you what it would look like on your calculator, is that the calculator really doesn't care what letters I use. All the calculator cares about is whether or not the letters match. So I could use any alphabet letters. If I wanted to use Y, because that's how this reads, then on my calculator I would simply use the alphabet for Y, not the Y1 function, the alphabet. So I could use alpha T, U, V, Z, theta, anything that I want, S, N, it doesn't matter. I could even use all the lowercase letters if I so chose. I would just use the second button and get a lowercase letter if I wanted a little u. Doesn't really matter what I use on the calculator. I would get the same answer regardless. What's important is whatever you put in the calculator, if these are letters or variables, they have to match. Okay, so this is not the same. The alphabet Y is not the same as Y1 on the calculator. It's just a regular letter. So if I were going to finish this out by hand, which I would need to be able to do, I would simplify first. So I have 3 minus y squared minus y, and distribute the negative minus 1. So I really have a negative y squared, a negative y, a positive 3, and a negative 1 makes a positive 2. dy. So I have negative 1/3 y cubed minus 1/2 y squared plus 2y from negative 2 to 1. So if this were a free response question by hand, I would simply substitute in negative 1/3 minus 1/2 plus 2 minus negative 1/3. I wouldn't even simplify. Negative 2 cubed, negative 1/2, negative 2 squared, plus 2, and negative 2. I wouldn't even simplify it out. When I substituted the 1 in, I really didn't try to write 1 cubed because that's silly. But I didn't simplify any of that. That would be my free response answer, 100% credit. Otherwise, I would have to find common denominators. This would be negative 2 6, negative 3 6, plus 12 over 6, minus negative 2 times negative 2 times negative 2 makes positive, it is negative 8, times negative 1/3 makes positive 8/3. Negative 2 times negative 2 makes positive 4. Positive 4 times negative 1/2 is negative 2, and then minus 4. So now I have negative 2 over 6, negative 3 over 6, plus 12 over, I guess I could put those together. I'll go ahead and do that. So I have 12 minus 5, so I have 7 over 6, minus, I have negative 2 and negative 4 is negative 6. So that would be 16 over 6 minus 36 over 6. So now I have 7 over 6 minus negative 20 over 6. So now I have 27 over 6, which makes this 9/2, which in fact is 4.5, which is exactly what I got with my calculator. Okay, so big things on here, upper minus lower dx, right minus left for dy. Okay, for each of these problems, I am going to do a sketch. I am not going to make a perfect graph. This is x squared plus 2x plus 1 and the line 2x plus 5. First thing I want to know is, do they intersect? Maybe the line is completely underneath the parabola and never intersects. So we want to make sure what we're doing there. But I do know that I have a right side up parabola and I have a line. So if I set those equal, x squared plus 2x plus 1 has to equal 2x plus 5. When I subtract 2x, those are going to cancel. I'm left with x squared minus 4 equals 0. So x equals plus and minus 2. So I have some sort of right side up parabola that crosses this line. So if x is 0, y is 5. And I know that these graphs are going to touch. And they intersect at negative 2 and 2. Other than that, I don't care. It's a right side up parabola, crosses that line twice, so the line has to be on top. So we're looking for this area. So that means the integral is negative 2 to 2. The line was on top, minus the parabola that's on bottom, and just bank those points in. So I'm really more concerned right now that you can set them up than go through all the areas. You can either go through by hand, or you can go through now and do them with your calculator. Okay. Do be able to simplify algebraically in antidrive. Okay, for this one, I have a right side up parabola and an upside down parabola. Let's see if they intersect, because they could miss entirely. So if I set them equal, x squared minus 4x plus 3 has to equal negative x squared plus 2x plus 3. The plus 3's are going to cancel. I'll end up with 2x squared minus 6x equals 0. So the GCF is 2x, leaves me with x minus 3. So these graphs are going to intersect at x equals 0 and x equals 3. I do not care exactly what they look like. I have an upside down parabola. I have a right side up parabola. They intersect at 0 and 3. So this is my Star Wars Empire plane. It's the bad guys. So my integral from 0 to 3 is the upside down parabola on top minus the right side up parabola on bottom, dx. So again, work right now on making sure you can set them up. Not as much the algebra. That's really on you to be able to do that at this point. And anti-deriving polynomials and trig and exponentials. Okay, this graph with x squared and x cubed is one that more students miss because they put the values upside down. The x squared graph is not smaller than the x cubed graph, except past 1. So at 0, 0, they're going to intersect. At 1, 1, they have the same value. But the x cubed graph is smaller for that particular portion. Everywhere else, x squared is going to be larger. Everywhere else, x squared is going to be larger. X squared is larger for the left-hand side. X squared is larger here. X squared is not larger for this part. But for more of the graph, x squared is actually bigger than x cubed. If you set them equal, a lot of people miss some of the zeros. That means 0 has to equal x cubed minus x squared. So if I factor out x squared, I get x minus 1. So I have x equals 0 and x equals 1 only. But the x squared graph is larger. And I know that because if I were to try 1/2 squared, I would get 1/4. If I try 1/2 cubed, I get 1/8. So the square is larger for that particular interval. So from 0 to 1, it's x squared minus x cubed dx. And if I remember correctly, your answer should be 1/12. Okay, for this next graph, I want to set the functions equal. So x minus 1 cubed has to equal x minus 1. If I subtract over, the easiest way to do this one, I'm going to put this in parentheses, equal to 0, is to pull out the GCF of x minus 1. That leaves me with x minus 1 squared minus 1 equal to 0. So I have x minus 1, x squared minus 2x, and then the minus 1 plus 1 here and the minus 1 cancel. So I actually have x minus 1 and a GCF of x, and then an x minus 2 left over. So x equals 0, x equals 1, x equals 2. So if I were to graph this, x minus 1 is going to pass here. That's my sketch. X minus 1 cubed is then going to have to hit here. So for the first portion, between 0 and 1, and then over at 2, between 0 and 1, the cube is on top. So from 0 to 1, we have x minus 1 cubed minus parentheses x minus 1 dx. Plus, from 1 to 2, I have the line x minus 1 minus the curve dx. This would be a good one for you to practice. Let's say putting this function into y1 and this function into y2. Now another way to do this one, if this were a calculator question, if it's a calculator question, okay, then you can get away with never writing the function down at all. If it's a free response that you have to do by hand, or it's a non-calculator multiple choice, you really are going to have to write these functions in. But you can still get the first points either way on the free response. On a free response question, I could have written this as 0 to 1, f of x minus g of x dx, plus 1 to 2, g of x minus f of x dx, and gotten full credit to bank those first 2 points. Even if I have to do the functions by hand later, I can get the points just by writing this part out, especially if I'm running out of time. and I get full credit even though I haven't simplified anything, I haven't anti-derived anything, or gotten a final answer. I get the setup points because that is the correct order. For this portion, f is on top of g, and they named the functions f and g. Okay. For this next problem, if we're going to do 1 over x squared, we need to know what that parent function looks like. And so we're going from 1 to 5, like this. So we don't have to worry about this asymptote being an issue. And it's the area between the curve and y equals 0. Y equals 0 is the x-axis. So technically we're doing from 1 to 5, 1 over x squared minus 0 dx. So this one we should definitely expect to have anti-derived by hand. This is not the natural log. 1 over x squared is x to the negative 2. We can only do linear x to the negative 1 or 1 over x or 1 over a linear u value that we substitute using natural log. So this is going to be x to the negative 1 over negative 1 from 1 to 5. That makes this negative 1 over x from 1 to 5. That's negative 1 over 5 minus negative 1 over 1. So if this were a free response, that would be my happy answer. If it's a multiple choice, it's negative 1/5 plus 1. So 1 minus 1/5 leaves me with 4/5. So you would see the answer on a multiple choice non-calculator as 4/5. Okay. Okay, so this next problem. On here, we would want to do this with our calculator. And after we graph them, we're going to find the intersections. Notice that we're starting at x is 0. So we're going to graph. On here, notice that this square root, which I've kind of covered up a little bit, does not extend across the 1. The 1 is completely outside the radical. So make sure if you have the new calculator that you're out from under the radical before you do the plus 1. If you have the old calculator, make sure you close the radical, close the parentheses before the plus 1. And then we have x. So if I graph, if I want to find the intersection, here we come up with this. Okay, now we are finding the area starting at x is 0 between these curves. So we're going to start at 0 and we're going to go to this value. Now remember what I said at the beginning about the free response every year is 3 parts. Part A, Part B, and Part C, area, volume, and then volume a different way with a different shape. Every year. That means that if this question is a calculated question, you absolutely want to store these values because you're going to have to use them over and over again. Okay, so what I'm going to do, and I have to write this in the work part. So you have to write this in your work part of Part A. Once you've written it down in Part A, you may use this throughout the entire problem, A, B, and C, without having to restate it ever again. Let A equal 4.7912878. Never round in the middle of a problem, ever. So that means that I have an unrounded A that I'm now going to use. I'll write it right there. And I'm now going to write, since this is a calculator question, never going to write the functions down again. The curve is on top of the line, so that means f minus g dx. So on my calculator, I have that intersection. That's the last value I had for x, so I can type that here to double check. It's still correct. I can store that in alpha a. Now that means when I do the integral, I can do the integral from 0 to alpha a. I can double check y1 and y2. I could also write that down on my paper as long as it's not part of my work section. It has to be at the top of the page. I can then put those values in here as just y1 and y2 and never have to write them down there either or type them in again. So it's y1 minus y2 dx. So 5.423. Okay, the cube root of x and y equals x. Y equals x splits at the 45. The cube root of x is going to look like this. So we have our intersections at 0, 0, 1, 1, negative 1, negative 1. So from negative 1 to 0, it's line, which is g of x, minus curve, which is f of x, dx. Plus, from 0 to 1, it's the curve on top, so f of x, minus g of x, dx. For this next function, notice that we have everything in terms of y instead of x. So just as a note, remember that a y squared is going to open in the positive direction this way. A negative y squared is going to open in the negative direction. So this is a negative y squared. So if we're looking for the intersections, 2y minus y squared has to equal negative y. So 0 equals y squared minus 3y. So y would have, if I factor out y times y minus 3, then y equals 0 and y equals 3 are the intersections. The function x equals negative y is really the same as y equals negative x. So graphically speaking, y equals negative x would be here. And so my sideways parabola going backwards intersects at 0 and 3. Have to intersect here, we would have something like this. And I guess I really don't care if it's specific after that. We only care about where these intersections are, so we don't really have to make it a specific size, and we really don't care about the scale. So we're looking for this area here. So the height is determined by the x part this time. That means our function is dy, which means we have to use the y values, 0 and 3. So it's 0 to 3, the right function, which is 2y minus y squared, minus the left function, which is negative y, and this is dy. So remember, if you have x is your dx, upper minus lower, you have to have x limits. But if you have y limits, it goes with the dy function. It has to match. Our next set of functions are 2 sine of x and tangent x. So between negative pi over 2 and pi over 2, tangent x is going to have asymptotes. And 2 sine of x is just going to be a taller version of sine. And then this is going to come down here. So we're talking about these pieces which are varying between who's on top. So the integral from negative pi over 2 to 0 is the tangent function on top. So that's g of x minus f of x dx. Between 0 and positive pi over 2, the sine function is on top. So that's f of x minus g of x dx. Okay. Now, graphing between 0 and pi. I'm going to start that a little further over. Thought better. 2 sine of x makes sine larger. If we have pi over 2 and pi. Sine at pi over 2 is going to be 2 times 1, so 2. And then we're going to have 0 at pi. Cosine of 2x is going to be a little different though. Cosine of 0 is still going to be 1. But at pi over 4, if we substitute pi over 4n, we're going to get cosine of pi over 2, which is 0. At pi over 2 substituted n, we're going to get pi, which makes the -1 value. And then we get 0 again, and then cosine of 2 pi would be 1. So we're going to have this situation. Okay, so setting this up between 0 and pi, it's going to be like a candy wrapper. Kind of a little weird situation going on. Okay, so if we were to set these two functions equal, that would mean that 2 sine of x has to equal cosine of 2x. That means we need to use our double angle formula so that 2 sine of x is equal to 1 minus 2 sine squared x. So we're using the trig identity for cosine 2x that involves sine, or sine only rather. So that means that I would have 2 sine squared x plus 2 sine x plus 1 equal to 0. This factors as 2 sine x plus 1 times 1 sine x plus 1 equals 0. So we get 2 sine squared. Actually, I'm trying to think if that actually will factor. I don't actually believe it will. Oh. So we might want to look at our calculator for that one. Sorry, guys. All right, so on here, we really won't need our trig identities then for this particular problem. We're going to use our calculator to set it up. So we're going to type into the first part 2 sine x, second part cosine of 2x. Make sure your mode, since we're doing sine and cosine, is in radians. And I'm going to do my window so that it matches the window that we need. From 0, my window from 0 to pi. And then graph. So there is my sine function and then my cosine function. If I want to make this a little nicer, I could zoom 0. If I zoom trig, it's going to change my x values to the -2 pi to 2 pi, so I don't really want to zoom trig very often. So if I look for my intersections, we have 0.374. So I'm going to say on here, let A equal 0.374734443. And then I'm going to go back and get my next intersection. First curve, second curve. So I'd like to have my guess be closer to this side. So 1, 2, so maybe 2.5 would be my guess, so that I find the value that's close to 2.5. Okay, so then I'm going to write that one down as well. So I'm going to say let B equal 2.7668582. So now my integral can be a little bit lazier. From 0 to A, we have the cosine curve on top. Oops, sorry. So that is g of x minus f of x dx. Plus, from A to B, we have the sine function on top. So that's f of x minus g of x dx. Plus, from B to pi, we have the cosine on top again. So that's g minus f dx. Now with my calculator, I can fairly easily get those areas. Oh, so one thing I did forget to do is I forgot to store my values. So I'm going to calculate my intersections again really quickly. And I said this second value is b. So while I have that value there, I'm going to do x and store in b. The first value, when I calculate my intersection, I don't want to have this value again, so I'm going to guess closer to 0.5, or I could do 0.3 so it would get there a little faster. And I'm going to quit, and that x value, I'm going to store in a. So we're going to do the integral from 0 to a of y2 minus y1 plus the integral from a to b of y1 minus y2 plus the integral from b to pi of y2 minus y1 again. So 4.807. Okay. Now, one of the features that I want to make sure you know how to use on your calculator is the draw feature. So this question says to find the area bounded by this curve and the line tangent to the same curve at 1, 1. So I can ask my calculator, if this is a calculator question, to graph the curve x cubed. I need to zoom back out to my standard window. And then after I graph, I can have it draw, which is second program button, the tangent line, number 5. And then I have to tell it where. Doesn't read my mind. This is not the Johnny Depp movie Transcendence. You got to tell it where. At x is 1. Not only will the calculator draw the curve and then draw the tangent line after you ask it to, it'll tell you the equation of the tangent line there. So again, your first step has to be to graph x cubed, and then use the draw feature, which is second program button, number 5, which is the tangent line, and then you have to tell it 1 because that's the value of x we want to use. Okay, now the equation of the tangent line is y equals 3x minus 2. So the area that's bounded is here, because after that our curve splits up from the line and there's no bounded area, and on the bottom it's going to split across as well and have no bounded area like this. Okay. So now for that entire interval, x cubed is on top. So it is x cubed minus the line 3x minus 2 dx. Now the interval is going to matter. We do know the stopping point was the point tangency. The tangency point is at x equals 1. We need that initial value, which is why also we're doing this with our calculator. That initial value is not a nice whole number. Intersect number 5, enter, enter, and we want to find, whoops, forgot to put something in there. I do actually have to. It drew a picture of the line, but it didn't actually store the equation of the line. So let's store the equation of the line first, and then graph. Okay, so after we store the equation of the line, we can intersect and try to find the point of intersection, and it gave me -2, -8. So down here at -2. So the area from -2 to 1. So our area then on our calculator we remember put these in, so I can make kind of a side note that that was y1 and that my tangent line was y2, and then use my calculator to evaluate that. I just can't have the work have any of the calculator notation. So I'm going to do the integral from negative 2 to 1 of the y1 function, which is the original curve, minus the tangent line that we stored there, dx. Oops. So 6.75, or it may even have you frac, but you should know how to frac it. 6.75 or 27 over 4. Okay. Now this next part, the vertical line x equals v divides the region between this line and the x and y axis into two equal areas. Okay, the question is never going to be where's the x value that's in the middle. Okay, so between the x-axis and the y-axis in this line, if x is 0, the y value is 16. If x is 8, then the y value would be 0. So we're talking about the area between the line and those curves, like here. So this triangle. So the x value being 4 is not going to cut this shape in half. So the way we want to set this up is there's a vertical line where x equals b, where this cuts the shape's area in half. That means the integral from 0 to b underneath this curve should be half of the total area. Now, the reason I didn't write down the integral for the total area, you could do the integral for the total area from 0 to 8. But this is just a triangle. I shouldn't throw out all the other math that I know, especially when the AP will accept you doing regular geometry to get this answer. This is the area of a triangle, which is 1/2 base times height. So that's 1/2 the base of 8 and the height of 16, which makes this 64. So we want the integral from 0 to b, which is 16x minus x squared from 0 to b, to be half the total area, and the total area is 64. So we want this to equal 32. So if I substitute in 16b minus b squared minus 0 has to equal 32. So in my calculator, I could then put this as y1 and this is y2. Again, these notes are for me. I would not actually have those notes on my AP paper. I could do that somewhere off on the side if I want to. So I want to know where those are equal. So I want 16x minus x squared to equal 32. Okay, so if I can't see, I could zoom 0 to see what else is going on. So I can calculate the intersection. I get 2.343. So B equal to 2.343 actually works. Notice that there was another value further along where this parabola would have touched. So if I change my window to say 0 to 20, but that value is invalid. The value further out would not divide this triangle in half. 13.65, that's out here somewhere. Okay, that can't possibly divide the area of that particular triangle in half. Just won't work. It has to be between 0 and 8. So this is the only valid value of B. Okay. The last thing about area and volume, area that we want to know is something that could give you a bit of a shortcut. Even and odd functions. Even functions, functions like cosine of x, x squared, a perfectly balanced even w for Westfield. if I find the area from a negative side to the same distance on the positive side, the left side of the graph and the right side of the graph have the same area. So the areas are also symmetric. So that means that I could say when I have an even function that the area from negative a to a is the same as doing the area from 0 to a, so we're just doing this side and doubling it. Even more interesting are functions like sine of x, x cubed, functions that are balanced across the origin. If I go from negative a to positive a, these two areas are equivalent, but they're the opposite of each other. So the areas cancel. So if it's an odd function, it doesn't matter where I start. If I go the same distance across, the area is just 0. You don't even have to prove that they're odd and even functions all the time to do this. Sometimes free response questions on older questions do ask you for odd and even proof. But 3 is really x to the 0. If all the terms are even if I threw a cosine at the end of this, x to the 4th, x squared, x to the 0, cosine, those would all be even functions. I can divide this up so that I do double of just the right-hand side. The reason that I would want to be able to do that is because it's so easy to substitute 0 into polynomials. I don't have to worry about whether or not a negative times a negative or a negative squared becomes positive or negative or what's going on with those. So 1/5 x to the 5th minus 4/3 x cubed plus 3x gets doubled from 0 to 4 instead. So I have double of 1/5 4 to the 5th minus 4/3 of 4 cubed plus 3 times 4 minus 0. And I don't even have to enter because this is a polynomial. These are all going to be 0. I don't even have to substitute in. This is my free response answer. Saves me a lot of time and effort. I can even, if I have a function that can split up, I can even split this up because it's adding and subtracting to be 2, which is an even, plus x squared, which is even, dx. So I'm taking the x to the 0 and the x squared, plus from negative 2 to 2, the odd part, x plus 3x to the 5th dx, and use the rule, both rules on the same function. I just have to split it apart. So remember, plus and minus are normal, so I can split this. That means for the even part, I'm going to do double the zeros. So I'll double from 0 to 2, 2 plus x squared dx. But for the odd function is going to cancel out. From negative 2 to 2 on any odd function, fully odd function, simply cancels. So that's just 0. So I don't even have to do that part at all. So I never raise anything to the 6th power and have to find common denominators. None of that's necessary. So I'm going to double the integral, which is 2x plus 1/3 x cubed from 0 to 2. So on a free response, I would simply substitute in, get 4 plus 8/3 minus 0, and be done. Worst case scenario, it's a multiple choice, and I have to do 12/3 plus 8/3 doubled. So I'm doubling 20 over 3, and the final answer is 40 over 3. Still, I've saved myself all the headache of substituting negative 2 into this, subtracting negatives to do the double negative, and we don't have to worry about that. We should have gotten a larger value. So again, this is like x to the 0 power, so those are both even, 0 and 6. So I can double from 0 to 2 instead. So that's double 1/7 x to the 7th plus x from 0 to 2. So that's double 2 to the 7th over 7 plus 2. Oops, should have written it down as minus 0. Technically minus 0, but that's why we like 0 so much. It's also doesn't always cancel off, but it's easy to substitute into other functions as well. So if this were a free response, that would be my answer. If this were a multiple guess, I would have to have a common denominator, so this would end up being 14 over 7. And 2 to the 7th I could work out. Regardless of how I do that, I usually start with 2 to the 5th is 32. 2 to the 6th would be 64, so 2 to the 7th would be 128. That's really literally how I start mine. So then I have 128 plus 14 is 142 over 7. So my final answer on a multiple guess would be 284 over 7. Either way, it's much easier to get this done and much quicker than if I'd used the -2. The end.